Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 90. Lesson number 90, we are in the process of learning how to solve linear equations. Lesson number 90. Let's see what we have for today. The first problem we have looks something like this. X over 4 plus x over 3 over 5, x minus 3 over 5 equals 3. And our job is to find out what value of x will satisfy this equation. That's how we speak. To satisfy an equation means work for it. So first thing first, we have to find a common denominator of 4 and 5. The common denominator of 4 and 5 is 20. The question is, how do we turn this 4 into a 20? By multiplying this term by 5 over 5. Because if you have x over 4 or some number over 4, if you have some number over 4, 8 over 4 is 2. If I were to take that and multiply the top and the bottom by 5, I'm not changing anything because 5 over 5 is 1. You can take any number and multiply it by 1, it's not going to do anything. 5 over 5 is 1, incognito, in disguise. So that takes care of this part. Now we have 20 at the bottom. 5 times 4 is 20. How do we convert this 5 into a 20? By multiplying the top and the bottom by 4. Now we have a 20 here, we have a 20 here. It would be better if we had a 20 here. So let's multiply the top and the bottom by 20 here. So now that we have 20 or the last part we didn't have to do that if we didn't want to. Just keep it like that. Or do it if you like. 20 over 20. So now we have 20 everywhere. So if you have 20 everywhere, for example, if you have 40 over 20 plus 60 over 20, that's a 2 plus 3 is 5, so that's 100 plus over 20. As you can see, this equation is a valid equation. 40 over 20, which is 2, 60 over 20, which is 3, 2 plus 3 is 5, which is 100 over 20. And because it's a valid equation and because they have the same denominator, if I were to get rid of the denominator, the equation will still hold. The equation will still hold. The equation will still be true. So that's what we're going to do. Now we can get rid of the 20. We just have to worry about the top. So let's do it. So here we have 5 times x, which is 5x. Here on the other hand we have 4 times x minus 3. Let's put it here for the time being. And on this side we have 3 times 20, which is 60. Let's open this guy. 4 times x is 4x. 4 times negative 3 is minus 12. Equals 60. And here we have 5x. Now we have to add the like terms. Add the like terms, which is what we did day number 21 through 50. We learned how to add and subtract like terms, algebraic expressions. Here we have 5x and a 4x. 5x plus 4x make a 9x. 9x minus 12 equals 60. Now we have to get rid of this negative 12 from this side because we want to keep all the unknown on one side, all the known quantity on the other side. And the tradition dictates, convention dictates, that we keep all the unknowns on the left hand side and all the numerical values on the right hand side. So somehow we need to move this 12 to the other side. Let's add 12 to both sides. Negative 12 and a positive 12 cancel out. And we end up with 9x equals, this 9x comes down. If it bothers you sitting over there, put it here if you like. 9x equals 60 plus 20, which is 72. And now we have to divide both sides by 9. And I'm running out of room. Can we erase this bottom part here? I think we can erase this bottom part here. What it says is that if the sum of the digits of a given number, is divisible by 3, then the number is divisible. Number itself is divisible by 3. You see right here, 7 plus 2 is 9. 9 is divisible by 3. Therefore, 72 is divisible by 3, which is what we're going to do here. Because I don't know what 72 divided by 9 is, so I'm going to do it step by step. I don't want to erase this thing. Let's leave it there. We can erase this part. We don't have to worry about it. We already know that 0 divided by any number is 0. We know that already. 0 divided by any number is equals 0. We know that already. Let's erase that. Let's erase that, and we're going to continue our work. We're going to continue our work here. 9x equals 72. We're going to pick this up here. 9x equals 72. As I said, I do not know what 72 divided by 9 is, so I'm going to divide by 3 first. So 9 divided by 3 is 3. How many 3's in a 7? There are 2 3's in a 7. And the remaining one goes here, becomes a 12. There are 4 12's in a 3. And this 3 of course cancels out because we're dividing by 3. So now we have 3x equals 24. Now we can go one more round, divide one more time by 3. This 3 cancels out, and x equals 24 divided by 3, which is 8. Of course it's 8 because it was 72. 9 8s are 72. What was I thinking? Of course, 9 8s are 72. And how do I know 9 8s are 72? Because 10 8s are 80. 10 8s are 80. So if you were to take away one 8 from 80, it would be 72. 9 8s are 72. We could have divided directly by 9. I didn't have to go in 2 steps. But anyway, the answer is x. Answer is x equals 8. Let's verify it, shall we? Let's verify it. There's a lot going on here, so that kind of tricky to verify here without erasing anything. Right here was the thing. We can verify right here. X equals 8. So tell you what, in order for us to verify it, I'm going to take out the things we don't need. Right here, we do not need it. We do not this thing, and we do not need this thing. This is what was given to us. Let's put it x equals 8 in here and see if it works. 8 divided by 4 is 2. 8 minus 3 is 5. 5 divided by 5 is 1. 2 plus 3, 2 plus 1 is 3. Voila. It works. One more time, I'm going to explain it. We just found that x equals 8. We put it in here. 8 divided by 4 gives us 2. And 8 minus the 3 is 5. 5, the start quantity is 5, divided by 5 is 1. 2 plus 1 equals 3, which is what we have. So it works. That's it. Want to do one more? Yes? Let's do one more, shall we? Let's do one more. I need to erase everything because we need the room. The next problem that we have looks something like this. 4m over 3 minus 2m over 4 equals 5 over 2. Let's see what we can do. Again, the common denominator of 3 and 4 will be 12. How do I make this 3 into a 12? By multiplying top and the bottom by 4. Again, if I multiply 4m over 3 by 4 over 4, 4 over 4 is 1. I haven't changed anything. How do we convert this 4 into a 12? By multiplying top and the bottom by 3. How do we convert this into a 12? Multiply top and the bottom by 6. So now everything has a 12 at the bottom. 4 times 3 is 12, 3 times 4 is 12, 2 times 6 is 12. Since everything has a 12 at the bottom, it looks something like this. 60 divided by 12 minus 48 divided by 12 should equal 12 over 12. Let's see if it makes sense. 60 divided by 12 is 5. 48 minus divided by 12 is 4. 5 minus 4 equals 1. 12 divided by 12 is 1. It's a valid equation. But notice what happens. It is a valid equation. But because we have the common denominator, same denominator everywhere, 12, 12, and 12, that 12 plays no role. We can get rid of this 12 and the equation would still be a valid equation. Watch this. 60 minus 48 equals 12. Voila. You see? That's what we're going to do here. Because the 12 appears everywhere at the bottom, we can ignore it. So what we have now is 4 times 4m. 4 times 4m, 4 times 4m, minus 3 times 2m, 3 times 2m equals 5 times 6. 4 times 4m is 16m, minus 3 times 2 is 6m equals 60. Oh, sorry, 30. 5 times 6 is 30. 16m minus 6m is 10m equals 30. How do we figure out what m is? Divide both sides by 10. Divide this side by 10, divide this side by 10. This cancels out and m equals 30 divided by 10, which is 3. M equals 3. Now we have to go back in our original equation and make sure that it actually works. Verify it. M equals 3. M, we just found, m equals 3. Voila. M equals 3. Let's put it back in the original equation, and in order to do that, I'm going to get rid of all the extra stuff that is there, so this is not confusing to us. All the extra stuff is going to go, and it's going to look like the equation that was given to us. This is what was given to us. If we put 3 in here, 4 times 3 over 3, 4 times 3 over 3 gives us 4, minus 2 times 3 over 4 is going to give us, this 2 is cancelled out because this 4 is 3 halves. And we are told that that equals 5, 2. Let's see if it works. Let's see if it makes sense. Listen carefully. This is 4. Perhaps I should do it. I'm going to erase all of this thing because it's getting too crowded. I'm going to erase all of this thing and we're going to do the confirmation separately. Okay? Watch here. We don't need any of this. We already know m is equal to 3. Instead of squeezing everything on the top, because it's kind of nasty, let's do it on the bottom. 4 times 3 over 3 minus 2 times 3 over 4, it has to equal 5 halves. This 3 cancels out. This 3 cancels out. 4 minus, and this 2 cancels out with this 4 becomes 2. 3 halves. How much is 3 halves? 3 halves is so called because 3 halves is made up of, guess what? 3 halves. 1 half, second half, third half. 3 halves are 1 and a half. Because 2 halves is going to make a 1 and a half. 1 and a half. So 4 minus 1 and a half is 2 and a half. And how much do you suppose 5 halves are? 5 halves are so called. 5 halves are so called because it is made up of, guess what? 5 halves. 5 halves. 2 halves is going to make a 1. Another 2 halves is going to make another 1. 1 plus 1 is 2 and another half. 2 halves. There you go. 2 and a half. Not 2 halves, or rather 2 and a half. 5 halves is the same as 2 and a half. Which is what we found here. 4 minus 1 and a half. This is 1 and a half. 3 halves, as I already explained, is 1 and a half. 4 minus 1 and a half is 2 and a half. 5 halves is 2 and a half. It works. It fits. Everything is fine. That's all. That was the end for today. I will see you tomorrow on day number 91. We have 10 more days to go. Day number 91 through 100. We have 10 more days to go where we're going to learn. We're going to keep doing linear equations. And at the end of the 10th day, 10 days from now, on the 100th day will be the end of this topic, linear equations. And from day number 101, we're going to start solving word problems. And we're going to do that for the next 100 days, 101 through 200. Alright? I'll see you tomorrow. Bye-bye.